There is no native component in Grasshopper for unrolling irregular meshes. Kangaroo can unroll some specific morphologies, or there are external plugins like Ivy, but there is a common command in Rhino that is unroll surface. We can convert this mesh to a polysurface, or BRep, by taking the mesh face boundaries, creating a boundary surface, and then using BRep join. The Rhino command can be accessed in a Python script through the Rhino script syntax. In Rhino 7, this will return individual surfaces that will need to be joined. In Rhino 8, it will be a joined BRep and will need deconstructing. The order of the faces has not changed, but the order of the vertices has to change. This complicates things, because the custom texture map needs to be applied by giving UV coordinates for each vertex. I have written a script that makes this translation and constructs the corresponding mesh faces. As inputs, it takes the original mesh, the individual face boundaries of the unrolled BRep, which must be triangular, and the vertex points of the joined BRep. The output is first, the list of vertices, unchanged, and second, a list of mesh faces in the format needed by the construct mesh component. The third output is the index of the mesh vertex values that each of the BRep vertices correspond to. Use this with a list item component to select the UV coordinates from above. That will now be in the sequence to be used on the unrolled mesh when input into another custom map component. To add tabs for building a physical model, we take the outer edges, join, and then explode to ensure they are all facing the same direction. Then offset the width of the tab. Evaluate these curves at 2 points, just after the start and before the end, and merge these with the original curve's start and end points to make a chamfered corner. The internal edges can be converted to a dashed pattern for laser cutting after printing. Depending on the geometry of the mesh, some manual adjustments such as flipping over, rotating folds that were unrolled in the wrong direction, or splitting into separate parts to avoid overlaps in the physical model. When assembling, it can be helpful to visually identify on the 3D model which faces correspond to one another. The selector at the bottom of the definition highlights these with a connecting line.